Hello everybody, my name is Pathman Math and welcome back to today's lesson. Today's lesson is a continuation from last week's lesson where we had covered logic and patterns but dealt with numeric patterns or arithmetic patterns. Following with our logic and patterns uh, series here, and we did numeric and arithmetic. Now this week we're covering geometric. So quick recap, last week with the numeric patterns, that was dealing with a sequence of numbers that followed a specific rule. The rule governed the pattern that we witnessed within that sequence of numbers. Okay? And it was either based off of addition, subtraction, multiplication, division, or some kind of combination of that governing that pattern of numbers, that sequence of numbers. Now, with the numeric patterns, we had used a general equation or general formula to be able to find that rule that governed that pattern. The general formula we had was y equals ax plus b, where our y was our next number in the sequence, x was our current number in the sequence, and then a and b were two constants that we used to be able to govern what the next number was going to be in our pattern. Now, A was the scale attached to our X, our current number. Okay. Now, some patterns, it's just going to be 1, and you're just adding or subtracting a number, which is going to be that B, which that B is our pattern constant. But for one of the examples that we did last week, we had one where it was a scale of 2. And going through that, we were able to keep working through, find our rule, and establish what our pattern was. Now, this week, we are dealing with geometric patterns. This is changing in the sense that instead of dealing solely with numbers, we are dealing with shapes as well. And with geometric patterns, we have a few different types of them based off of what kind of shapes we're dealing with, and uh, whether it's a pattern of alternating shapes or if it's a pattern of changing sides. Okay, so let's say we have these two stickers here. For an alternating pattern of shapes, different shapes, let's say we have a snail, then a snail, then we have the bee, then we have snail, snail, and bee, so on and so forth, following that same pattern. The rule that then governs it is not necessarily an equation, but it's more so just a written out rule saying that for every 2 snails, we have 1 bee. So we do snail, snail, bee, snail, snail, bee, snail, snail, bee, so on and so forth, all the way upwards to infinity. So that is an alternating sequence and an alternating pattern of shapes. Now, another kind of pattern that we could have is changing up the sides and creating an ever expanding image using shapes. So let's say we have an example here of a triangle. Okay, 3 sides here. What I'm going to do is create another triangle here by adding on 2 sides. Going to create another triangle here by adding on 2 more sides. Create a fourth triangle by adding 2 more sides, so on, so forth. I create, say the next one here, triangle, 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 triangle. I keep going through by adding on 2 more sides to it and keep expanding outward that image until we have this gigantic triangle composed of so many smaller triangles that we created by following the written out rule saying for every term we add 2 more sides to create another triangle. Something along those lines here, because that's what we did. We added 2 more sides, made another triangle, and we're good to go. Added 2 more sides, create another triangle, good to go. 2 more sides, another triangle, good to go. 2 more sides, another triangle, good to go, and kept doing that. So mostly for geometric patterns, you're going to have a written out rule that governs that pattern. Okay, it's not necessarily going to be a general equation like what we had with um, the numeric one, because with the shapes, a an equation like that isn't specific enough. Because what we could say is this is our current equation or our current term in our pattern, and this is our next one. And then what we could say is y equals equals x plus 2. Okay, we're adding 2. We then have to establish what that 2 is by stating that, hey, this constant here is going to be the 2 sides that we add on here. But just having this equation isn't enough. Because yes, we state that y is the next term, x is our current term, and then we have this plus 2 constant, but we then have to establish what that constant is, and that just sort of starts getting a little bit complicated in that you're needing to then still write out what 2 are we adding. Are we adding 2 triangles? Are we adding 2 sides? And if it's the sides, how are the sides then added onto the shape? In this case here, we add 2 sides to make another triangle, and we're good to go. Making sure that, hey, we are adding these 2 sides next to our current shape, okay? Because right here we add 2 sides, and we're making sure that we are sharing this side right here. But it'd be a lot easier just to write out the rule saying, for our pattern, each next term you add 2 sides sharing a side to the current shape, making sure to create another triangle. Something along those lines. It's just a short little sentence, but it explicitly states what we are doing with this pattern. Just having this equation isn't enough. It's not going to be enough because then we have to expressly state what each of our values here, our y, our x, and the constant of 2 here, what each of those is referring to, and how we are then using that to compile the rule for our pattern. And that just winds up making things more complicated, gets more wordy, whereas if we just write a short and sweet, simple sentence, that is the rule for this pattern. Okay? So this equation that we had, that we used all last week, that works perfect for the numeric patterns. For geometric, not so much. Yes, we can use it, but then you are having to explicitly state what we are then uh, attaching our constants to, what each of these values inside of our equation is referring to, and then that's just doing way more work. Work smarter, not harder, and using this, that's going to be harder because you're having to expressly state out what each of these values is referring to and how we then use each value in the current context of that pattern. So work smarter, not harder. Short little sentence to explain what we are doing with our pattern. So make this big. Erase this. Now this one should go pretty quickly because we're not having to solve for certain values. All we're needing to do is take a look at our pattern and then write a simple rule for it. And sometimes when you're dealing with geometric patterns, it can help to create a small table that states, hey, for this term and to go to the next term, you do this. This to this, this to this if you're dealing with like sides and such. Okay? But for shapes, alternating shapes, it's pretty straightforward. So, I'm going to do this. Let's do circle, circle, not the best circle, square, uh, star, circle, circle, square, star, dot, 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 so on and so forth. Okay? So, for this pattern here, pretty quick and easy to look at this. We have alternating shapes. We have two circles. We have one square. I write that quickly. And then we have one star. Then again, I'm going to say 2C for two circles. I'm going to say 1 SQ for square. And then 1 ST for star. Okay? Two circles, one square, one star. Two circles, one square, one star. Then it'll be two circles, one square, one star, so on and so forth, all the way to infinity. So, quick little sentence here for our pattern. We have, uh, let's just say it out loud because it'd be kind of long to write it out. But for this pattern, we would say, for this pattern, after two circles, we are followed by one square and then one star, and then the cycle or the pattern repeats. Okay? So, quick and easy. For this pattern, we have two circles followed by one square, followed by one star, and then the pattern repeats. Boom, boom, boom. Quick and easy right there. We have our pattern here right in front of us, and it's just that little sentence that expressly states what happens. Two circles, followed by one square, followed by one star, and then repeats. Now, because it is a pattern is a repeating occurrence of something. In this case here, you need to state after what the pattern is, in this case, two circles, one square, one star. You then have to expressly state that it then repeats. Once we have that little section here, this is our pattern. This is our pattern. Okay? Two circles, one square, one star, two circles, one square, one star. That's the pattern, and it repeats, 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 and it keeps going on to infinity and beyond. But that's what we have. Short little sentence expressly states out what the pattern is, and then it then repeats. If we don't say that it repeats, then we have a finite pattern. It's just these shapes right here, and then it ends right here. But it doesn't end. It keeps going. So always make sure you add in that bit there that says and repeats or then repeats, however you want to phrase that. Just make sure that you are stating what that pattern is and that it then repeats. Quick and easy, not too difficult for it. So let's go on, do another one. Triangle. Actually, no. I'm going to do up, up, down, down, left, right. Up, up, down, down. Run out of room on that side there. but then it's left and right. All right. So from this dot dot dot, I just expressly stated it out right there for us. Up, up, down, down, left, right. Up, up, down, down, left, right. Right here is our pattern, and then it repeats. So real quick, boom. For our pattern, it's up, up, then down, down, then left, then right, and then repeats. Right there, boom, good to go. We've got our pattern. Quick and easy. Alternating shapes is pretty easy to deal with. Okay? So, pretty sure you guys have a handle on this now. It's literally just look how many times a certain shape appears in this pattern, state how many times it shows up, then move on to the next shape, then the next shape, however many shapes you got until it then starts to repeat. Okay? So you could have a huge convoluted one of square, circle, triangle, X, plus, minus, up, down. And then it repeats then with the square, circle, triangle, X, whatever it was, and then it repeats and it keeps going on. You could have a very convoluted pattern. So as that pattern starts to get larger and larger, just be aware of where things start to repeat. So I'll do one more real quick one, just to kind of change things up a little bit. But using the same shapes. So say circle, circle, square, circle, square, square, circle, circle, square, circle, square. Oh, geez. Square. No, stop doing that. Dot, dot, dot. Okay. So it's not just a few things there. It's this, but it is a circle and square. But now we've got changing numbers of how many it shows up. So in this case here, our pattern goes with this. It would be 2 circles, 1 square, 1 circle, 2 squares. Since there's only the square here instead of a star, I'm just going to put an S there. And same thing here. 2 circles, 1 square, 1 circle, 2 squares. Okay? Now, writing this out, we'd say for our pattern, we have 2 circles followed by 1 square, followed by 1 circle, followed by 2 squares, and then repeats. It's the same 2 shapes, but now we've got changing numbers of how many is of each shape is there. So again, just look at the pattern and you've got it situated. Just be very clear there and expressly write out what that pattern is and always end on and repeats or then repeats. All right? So we're doing pretty good here. Excuse me, sorry, I apologize. Now, the next one I'm going to look at is the changing shape, the expanding shape. Okay. Now for this, what I'm going to say is, let's go back with the triangle one, kind of write this out a little bit better. So we've got one triangle here. Now let's say we've got triangle, 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 and triangle. Triangle, 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 bam, 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 expanding further onwards. Then gonna do one giant line, one giant line, one giant line here. Across the board. So we got 1, 2, 3, 4, 5. Then this right here is the bottom part there. Took that out a little too far. Fix that up a little bit. It's always hard to keep track of how many times I'm doing this. There, and then there. There we go. Because there's 1, 2, 3, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7. We got 1 there. There's the original 3. Carried that out just a little too far. Oh, jeez. Do not want to erase that whole bit. Not the best drawer here. But I am doing my best, and that's what matters. 1, 2, 3, 4, 5. Let's just shade that in. Have a giant fat line right there. Now in this case here, there, and there. Boom. Okay. Try to draw that kind of quick. Made a few mistakes, but corrected myself. That's fine. That's fine, because normally when you see assignments and stuff, they're making the shapes and everything here. But that's a lot of shapes there. I want to make sure I'm getting everything lined up here. All right. So with our expanding figure here, as you can see, added in more sides to each of the making more triangles here. Okay. Now for this, I'm going to start putting some values here. So we got 1 triangle here. Got 1, 2, 3, 4. Got 4 here. We got 1, 2, 3, 4, 5, 6, 7, 8, 9. Got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay. Now, this does follow a pattern that we can use an equation for. Okay? Because what we're going to be doing is expressly stating in our written rule what we are doing with how we are expanding the figure. Okay? But once we do that, once we have our written rule, we can then attach an equation to it. Because remember, like I said, if you use an equation for a geometric shape, you then have to expressly state what is occurring, what each of those terms in that equation are referring to. Okay? So, now, with this, we have to create a table. Okay? Now, I'm going to say X, and I'm going to say Y. Okay? So Y is dealing with how many is inside, how many triangles are inside each of the next term, okay? Each of the next step in our pattern, okay? Now with X, what I'm going to do for this is X is going to be increasing by a value of 1, okay? So we start with 1. We then go to 2. We then go to 3, go to 4, so on and so forth, so on and so forth. Now, what I mean by X is increasing by a value of 1, this is the first term, this is the second term, third term, fourth term of our series of numbers here, our pattern. Okay? So the next one would be 5, then 6, then 7, then 8, and da 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 da. Continuing onwards. Now, when you're dealing with geometric shapes, this is typically the type of table you're going to be working with. Your X value is going to be your term in that sequence of numbers. Okay? So for term or step 1 of our sequence, step 2, step 3, step 4, term 1, term 2, term 3, term 4, 1, 2, 3, 4. We then have to write what our equation is going to be based off of these values here. Now, y is going to be how many triangles is a part of the whole shape, okay? So in term 1, we have 1 triangle. In term 2, we have 4 triangles. Term 3, we have 9. Term 4, we have 16, okay? Now, this is where things start to get a little bit further, expand a little bit outwards in terms of what knowledge you currently have. Now, what we can see here is we have some addition, or better yet, multiplication happening, okay? If you look at this, or we can say division, however you want to view it, but in the end, with our equation, it's going to be multiplication. When you're looking at these values here for our x's, they all go into what the y value is, okay? So, 1 to 1, that's 1 times 1 equals 1. Quick and easy for that, okay? Now to get to from 2 to 4, that's 2 times 2 equal to 4. From 3 to 9, that's 3 times 3 equal to 9. 4 to 16, 4 times 4 equal to 16. And so on and so forth. Okay? Now, we're going to use something that I haven't talked about, but that you guys may have already discussed inside your own classroom with your teachers, is something called an exponent. Now, an exponent is a number that you set just above another number. Let's scroll down just a little bit. So let's say we have our 1 here. We have 1, and we multiplied 1 twice, so it would be an exponent of 2 equals 1. 1 to the power of 2. That's what you say in regards to an exponent, is 1 to the power of 2, because we are multiplying 1 by itself 2 times. Okay? Now the next one here is 2 to the power of 2, which equals 4, because we do 2 times 2, 2 by itself, twice. We multiply it there. Okay? There's 2 values here, 2 2's, and that equals the 4. 3 to the power of 2 gets our 9. 3 times 3, multiplied it there. There's 2 values there, 2 values of 3. And then we did 4 to the power of 2 to get our 16. Boom, we have our pattern here. In this case, this is our term. Each step of our pattern here. So in this case, to get from get through our pattern here, get from the x to the y, our equation is going to be y equals x squared, where x is our current term of our sequence. You plug in that value in, and then you get your value for y. Okay, so we've got this here. I'm going to erase this section here so I can just kind of clean it up a little bit. So with this table here, in our equation, y equals x squared, okay, now we specify Okay, here I would write out what the rule is. So let's say this, something along the lines of this. For our pattern, using the equation of y equals x squared, where x is our current term in our pattern, we find how many triangles are, let's say, how many triangles comprise the entire shape. Something along those lines. Okay? For our pattern, using the equation y equals x squared, where x is our current term in the pattern, and y equals how many triangles we have that comprise the entire shape. Okay? Because we have one triangle here. We have a full triangle here, but it's comprised of 4 triangles, which is our 2x, or our x squared here, with 2 equal to x. The next one, we have a whole triangle made up of 9 triangles, which is 3 squared, because it's our third term, and so on there. Next one, main triangle comprised of 16 triangles, which is our fourth term squared. Now the next one we would have would be 5. We can continue this on, and we would have 5, and then plug that in. Y equals x squared equals 5 squared, which is just 5 times, sorry, right into 2 there. 5 times 5, which, if you remember from our multiplication tables lesson, we have 25. So our y equals 25. We would then have a gigantic triangle comprised of 25 smaller triangles. And then we can keep doing that forever and ever and ever with each of our next subsequent terms in our pattern here. So this is what we've got here, looking at these 2 different types of geometric patterns, in particular with the one that we just did. Count how many shapes are comprising the main shape. Okay? Create your table where your x is your current term, first term, second term, third term, fourth term, so on, for however many shapes, however many terms that they have shown in your pattern. And then count however many shapes are comprising the main shape. We could have gigantic square. We could have a gigantic hexagon. We could have a gigantic rhombus made up of a whole bunch of smaller rhombuses, so on and so forth. A bunch of stars interlocking together into a gigantic star-shaped thingamajig, whatever it wants to be. I don't know how that one would work very well. If you want to try that, you can try that, because it's a lot of stars that you are then trying to stick together. But for this example that we've got right here, you have your main shape comprised of a bunch of smaller shapes. Your x is going to be your current term in that pattern, whether it's the first term, second term, third term, fourth term, so on. And then your y is going to be however many smaller shapes comprise the whole shape. Okay? Or however many lines that you've got. As we did with that very first example where we added in 2 there, that one would have been a simple, it's still written on a star. That one would have been y, which is however many sides we have, equal to, say, our current term plus 2. If we did it with the triangle, add on 2 sides, triangle, add on 2 sides. We have 1, 2, 3, 4, 5. Now we got 1, 2, 3, 4, 5, 6, 7. We're just adding on 2 each time. So you can still create equations for your geometric patterns, but then you have to make sure that you expressly state in that written rule what the terms, what the values in that equation are referring to. Okay? So I'm going to end this episode here. We went through both types. We went through two different types of geometric patterns here. We went through um, a comprising pattern where we kept expanding upon a specific shape and finding out how many smaller shapes comprise the whole one. And then the previous one was an alternating geometric pattern where we had certain types of shapes that repeated themselves in a specific pattern. Okay? So go back through if you need to take some extra notes, want to look at the examples again, take as much time as you need for it. But I appreciate you guys for sticking with me. Want to give a big shout out to I Am Joan Nielsen for her request of logic and patterns for this two-part series of lessons. And if you guys have any other requests, have any specific lessons that you are wanting me to cover, feel free to comment in the comment section below and ask me what you want to learn. I'll keep making these videos if people aren't wanting to uh, chime in with something just yet. That's perfectly fine. I will keep making videos. I'll be bouncing around with different lessons, but bring me your requests and I will do my best to explain things to you in as easier, best way as I possibly can to hopefully help you guys understand these different topics a little bit easier than what you may be covering inside your own classroom, inside the classroom that you take, or if you're just wanting to learn for fun, you don't know something, you want to learn something new, bring it on to me. I will do my best. Appreciate you guys for coming by, sticking with me through these videos. Uh, like, comment, subscribe, and I will continue to do these lessons for you guys. I am Pathman Math, and I will catch you all in the next one. See ya!